In this video, I'm going to describe some of the ways you can work these puzzles, but again, go to the Crazy Dad website for the best set of tutorials to get you into this. Here's some things that help me. One is to realize that this is 3 puzzles simultaneously. You're required to get 2 stars in each row, and 2 stars in each column, and 2 stars in each region. And that's what makes the puzzles so interesting, is that you have to satisfy 3 different puzzles simultaneously. Now what I also want to bring up is a procedure I found for using Crazy Dad's 4squares to get an additional tool to help with these puzzles. This is from the solution set of Volume 1, Book 100, the first 11 puzzles. And, well, actually, I'm missing a column here, but 9 of the first 11 puzzles. And what caught my eye was how similar all of these solutions looked to each other. There's no clumpiness that I would have expected from sort of random distributions. And it was that hint that got me to looking as to whether there were some patterns inside these solutions. Now let's look at a few of the solutions in a little more detail. I've isolated just the first 3 solutions from that page and repeated them. You'll notice that these patterns look roughly similar, but each one, of course, is different. What I did was, by considering 2 columns at a time or 2 rows at a time, I found a pattern. And the pattern was that there was always a set of 4 cells, altogether a foursquare, that didn't have any stars in them. So there's one there, one there, one there, etc., like that. So I made a grid of 5 by 5 instead of the normal grid, which is 10 by 10. And I put that grid over these. And if you put that grid over this first solution, you find that these 5 locations are foursquares with no stars in them. So this one is here, this one is here, this one is here. And I found that the same on the others, all of them that I looked at. So what I did then is made a grid which showed both the 5 by 5 squares and the 10 by 10 squares, and I located the intersections on the fine grid as to where they sat in the coarse grid. And these 2 by 2s, the foursquares, they sit on odd locations. The numbers, this is counting 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. These intersections are always odd. And that seemed to be the trick, that you have to find 4 cells, a foursquare, that is on an odd intersection and has no stars in it. And that's the case for these that I've drawn here. So here are some specific examples of things that might help you solve these puzzles. Let's start with the rows first. Let's look at or columns, I guess, in this case. I've got columns here that are partially filled in. But in each of them, you can add some information by just looking at the way the empty cells sit. So for example, in this particular column, there's a binary here, and there's a binary here. So there's 2 stars. And of course, they cause the loss of the adjacent cells. So that's a help. In this column, we have, instead of 2 and 2, we have 1 and 3. And that doesn't allow us to do anything exactly, because this could have the 2 stars in it, or this could have a star, and one of these could have a star in it. But we do know that at least 1 star, at least 1, maybe 2, but at least 1 has to be in here. And that means that there cannot be a star here, and there cannot be a star here. So that might be of help to you at some point. Now here's a more complex situation. Here's where I've got a column that has a star in it, and it also has 2 binaries sitting in it, and a binary that's touching those 2 binaries. This doesn't happen that often, but when it does, it's very useful. This particular geometry forces an interesting thing. This cell must be a star. And the reason is, if this one was a star, then it would force these 2 to be stars, which would put 3 in this column. So this one cannot be a star, and instead, this one is. So there is a star there, and it's forced by just the way the geometry falls. That finishes off that particular star. Now here are some simple shapes, just to remind you that sometimes it's useful to use 4squares to mark off where a star must be. So let's go here. Here's what I call 2 touching 4. These 2 touch these 4. So there has to be a star in one of these 2 places, and there has to be a star in one of those 4 places. And of course, these all look like this. Similarly, this one, if you notice, you can't put a star here because it would wipe out almost everything. But once you put a star there, you can think of it again as 2 touches 4. And the notation works again. Here's another one, 2 touches 4. A star here would wipe out these 3, leaving only 2, so you can't have a star there. And it becomes 2 touching 4. Here's a case where you can see that you cannot have a star here. It will wipe out these 3, and there's not enough left to have 2 stars. So these 2 go out, and that leaves you with 2 foursquares. Again, it might help your thinking. One last thing is this shape here. It's surprisingly useful. If you happen to have a star in any row or column that it sits in, it immediately forces this to be a binary, and the other leg of this has to have a star, which forces these all to be eliminated. So although you're left with a little bit, this shape plus that 1 star allows you to do a lot of work. Now over here, I've just got 2 cases of these super powerful foursquares that are in which all the stars are eliminated. So here's one at position 1 and 7, so it's at an odd boundary. So I'll mark it with a circle just to remind me that that's a special one. And then that forces one of these 4 squares to be a star, and one of these, and one of these. So everywhere in here, there has to be 1 star per little symbol there. And this also applies vertically. So the discovery of this one particular setup of an empty foursquare on an odd boundary allows you to insist on all those. Now these will interact with your pre-existing deleted squares and oftentimes give you stars and binaries where you would not have been able to put them otherwise. Similarly here's one at the 3-5 intersection, and it forces this to be a foursquare, this to be a foursquare, this to be a foursquare there. And a foursquare is a place where there has to be a star. Okay, so with that, I invite you to go ahead and look at the examples. You might appreciate trying the examples prior to seeing my solutions to see how you would have approached it. Thank you.